So we're finally on the last section of this chapter, in chapter 8. It's called Solving Equations with Radicals. So that's kind of the question of what we're going to be finding out today, is how do you solve equations with nth roots? So we're going to have some radicals here. And then we're also going to have this new term, which is called having something called extraneous solutions, and what that means and how that works with solving nth roots. So let's just go back, and what we're going to do today is just solve some problems that I think we should all know how to solve with exponents and roots. And then what we're going to be adding to this is we're just going to check our answer to make sure that it actually works and it's correct. For our first example, just a little quick reminder, how do we solve something like this when we want to just get x by itself? We will take the exponent to both sides, and we flip the exponent and make it 5/4 to both sides. 5/4. And this is something you could probably use your table with. Remember, the 5's cross out, the 4's cross out. We just get an answer here. So if you'd like to use your table, you can. I believe it would be 1,024. If you do the 4 through 256, you think you get 4. And then you raise it to the 5th power, which is 1,024. All right, and then we're just going to come over here and check our answer. So we're going to put 1,024 into the original. So here's the original. I'm just going to put 1,024 in there. So we have 1,024 raised to the 4/5. Question is, does that equal 256? And you can type that into the calculator, hopefully, and get the fact that it is 256. So we're going to practice doing some more of this, of checking our answer to make sure it works. Because I don't think we've really done that like all year, so this is kind of something new we haven't really done, but hopefully it's not too difficult. All right, another reminder of how to solve these kind of problems, which is what we're really going to be diving into today, is how to get rid of these root symbols. So how do you solve this? The first thing we're going to do is we're going to subtract 11. And we're going to get the cube root of x equals, this goes away, 5 minus 11 is -6. And the question is, how do you get rid of a cube root? Well, you could also think of this as being x to the 1/3 power, right? These are the same thing. So how do you get rid of a 1/3 power? We just flip this around and make it 3/1. So we're going to do the same thing here. We just raise it to the power of 3 on both sides. Remember how important we said this negative wasn't supposed to be included in the parentheses here, and we do need to have parentheses around this whole thing because we're raising both sides, specifically a -6 to the 3rd power. So over here, this crosses out, and you just get x. And then that part you can type into the calculator, which would be -216. Okay, then over here, we're just going to check the answer. On the left, we're going to do the cube root of -216 plus 11 and see if that gives you 5, right? That's the question. Put that into the calculator, we get, yes, we get -6 plus 11 equals 5. Add them together, of course, we get 5 equals 5. So it checks out. Sometimes, I guess for the most part, you could always do this process to see if you got the right answer. If that ever comes out to be wrong, maybe you did something wrong as well. Okay, now for a word problem. I'm going to try to solve one of these word problems that you might see in physics whenever you get to physics. It says, imagine spinning a ball on a string around in a circle. If the string breaks, the ball will follow a straight line path in the direction it was traveling at the time of the break, as shown below. So you have this picture over here, and it's giving you a formula that we're going to go through. But you got to pretend like there's a little thing here, and it's on a string with a ball at the end. So they have like the center point, and it's spinning around and around and around over and over. And at some point, the string on it that's being attached to breaks. And once that breaks, what happens is the ball wherever it was located around like this circle will go in a straight path this way. It goes right off wherever it ended or wherever it broke, it goes into a straight path this way. Or if it was somewhere else, it would go into a straight path and wherever it broke. It doesn't continue going around the circle. Hopefully that makes sense, right? Once you break the string, it goes off. Okay, so here we have our formula. The ball will travel at a velocity v given by this formula. So v is our velocity. I'm going to maybe underline some of this stuff. Equals the square root, big square root, of tr over m. T is the tension on the string. That's in newtons. M is considered the mass of the ball in kilograms. R is the length of the string in meters. Okay, so they gave us all the setup, what everything means. V is velocity. T is, where's T at? Tension on the string, newtons. R is length of the string. I think R is using for length because it's like a radius, kind of like R for radius, right? Okay, and that's all we have. So it says what tension is needed. So we're trying to figure out tension, right? We don't know tension. What tension is needed to allow a 5 kilogram ball on a 2 meter string to achieve a velocity of 10 meters per second. That's how you read that. I was going to shorthand it, but I didn't know if you would know what m per s was, meters per second. Okay, so let's go ahead and label some of the stuff. The 5 kilogram ball, that's how much it weighs, and the weight or mass stands for m. It's also in kilograms. 2 meter string is how long the string is, and that's right above it, r. And a velocity of 10 meters per second, so it's obviously going to go in for the capital V. And what we don't know is the tension. All right, so to set it up, I'm just going to copy the problem down, the formula. So it's going to be 10 equals, that's our velocity, square root, tension, we don't know, times r, 2, all over m, the mass of the ball, 5. And then we're going to unpack this and solve it, see what we get. So how do you get rid of a big square root like this? You can't unpack anything inside here yet. We have to get rid of the square root by squaring both sides. I do the same thing on this side. You don't need the parentheses because we don't have a negative here, so it doesn't really matter as much. 10 squared is 100. This will cancel out the square root. So we get t times 2 over 5. Of course, you could also make this 2t if you'd like. And then how are we going to finish this? We can multiply both sides by 5. I'll cross them out, and we'll get 500. Let's go over here. 500 equals t times 2, or 2t. Let's change that up now. And then we'll divide both sides by 2, and we get a tension of 250. Now this is in, what's the tension measured in? Newtons. 250, I think newtons is just a capital N, is a tension. And then we're going to do the same thing we've been doing this whole entire lesson, is check your answer. So we're going to go in and we're going to plug in the tension of 250 and just see if it gives us 10. So the square root of 250 times 2 over 5 and square root it. Okay, and then on this side we got to simplify it. So I'm going to keep going to the right here. So we have 10 equals the square root of 250 times 5 is 500 divided by 5. So that is the same thing as the square root of 100, 500 divided by 5. And then we get 10 equals 10, so it checks. A couple more examples. I think we have 2 or 3. 3 more examples, and we'll be done with this. It says find all real solutions. Okay, nothing different. So we're going to solve this by getting rid of the 8 first, subtracting 8. That goes away, and then we get the 6th root, positive 6th root of x equals a negative 3, 5 minus 8. Then we're going to get rid of the 6th root by raising it to the 6th power. Whoops. 6th power. Same thing over here. It gets rid of this. We get x equals, multiply that out 6 times, negative 3, negative 3. Looks like that's going to be negative 729, 729. Okay, now we're going to go over here and check. So we have 8 plus the 6th root of 729 equals 5. The sixth root of 729 is the number 3. Bring that down. So we have 8 plus 3 is 11 equals 5. Wait a minute. We did something wrong, right? Actually, no, we didn't. They do not equal each other. This is not the right answer. And there actually happens to be no answer in this case. This is not an answer. This is something called an extraneous solution. So this actually does not have a solution. There is no solution. It's something called extraneous. A word for the day. Right? So this means that we actually don't get a solution. We solved everything correctly. We did all the right steps. But when we did our check over here and went down through it, it does not work. This is not a right answer. And maybe you can look at these equations and figure out why that is from the very beginning. And I hope you can figure that out as we go through this. Let's talk about what this means. Extraneous solutions. So note, we still have to now check our answers in the original equation. So, because we're checking for this new thing called extraneous solutions. Extraneous. So extraneous solutions are answers that we get when solving equations, but they are not really solutions to the equation. And maybe over time, you'll figure out why certain things are going to be extraneous and why they may not be extraneous, why some answers work and don't work. So let's try another one and see if we get extraneous solution. Okay, so we're going to subtract both sides by 19. So we get the fourth root of x. This goes away. This will be the answer 5. And then we'll raise both sides to the 4th power to get rid of the 4th root. 5 to the 4th is 625. All right, let's plug it back in and see. So we have 19 plus the 4th root of 625 equals 24. These checks should not really take that long overall. I don't think they're really that bad. So we have 19, the 4th root of 625, you could use your table if you'd like, is 5. If you add these together, do you get 24? Yes, you do. So this is an answer. It's not extraneous. What's going on here? Why is this an answer? The last one was not an answer. All the previous ones have been answers, though. All the ones that we've done before, right? All these ones have been answers. Why is this one the only one that's not an answer? We're going to do one more, and maybe you can figure out what's going on. All right, last one. Find all real solutions. All right, we have a big square root over top of this, so we have to actually get rid of that first. So remember, there's like a little 2 here. So what we're going to do is we're going to square both sides right away. And this gives us 2x plus 1 equals negative 7 squared is 49. And then we subtract 1 on both sides. So 2x equals 48. Divide by 2. X equals 24. Really, I guess I shouldn't circle it until we're ready to figure out whether it's right or not. So let's do our check. The square root of 2 times 24 plus 1 equals negative 7. So the square root of 48 plus 1 equals negative 7. Square root of 49 equals negative 7. Square root of 49 is 7. Not negative 7. So we got another one where this does not work. This is no solution. The solution we got is extraneous again. Now why? Why do we have two extraneous solutions? What's going on? Well, let's go back to the original up here and talk about it. So why is this extraneous? What's going on here? The problem really lies in the beginning of the problem, in the original problem, the OG here. When you square root a number, we have a really big square root here. Whatever this number is, remember, you can never square root a number and get a negative out. Ever. Not possible. When you square root something that's negative, let's just put in a number, like negative 49, right? That doesn't give you negative 7. Remember, this gives you 7i. So it really isn't possible to you know, it's trying to find two numbers multiplied to give you the 49 here. And it's not possible. You can't do it without introducing imaginaries and getting into that realm. So this is actually like a false beginning of a problem. It's never going to work. Of course, you may not recognize that when you're doing the problem, but it turns out to be the case whenever you check your answer. We're so used to just doing the answer and circling and being done with it, but now we have to be wary about that. Now let's go back here. Now we have a sixth root. Now what's wrong with this one? Look at this one. When you do a sixth root of x, you also cannot have negatives in here. It also does not produce negatives. When you do a sixth root or a fourth root or a square root, these even powers here, it's a pretty big important thing. You either get imaginary numbers or it's just not going to work. So this has to be positive for it to work, to give you a real answer. And then how do you take a positive number and add 8 to it and get 5, right? The only way you can do this is if that root symbol in here is a negative, in this particular case, a negative 3, right? So how does that happen? It can't, not with a sixth root. It's not possible. Could you possibly get a negative out if it was a different root? Yes. If we had a cube root, in other words, if we had an odd root, you can get negatives out, right? We could get negatives. So specifically, if we had the number negative 27, that a cube root of that, we would get a negative 3 out, and that would work because a plus negative 3 is 5. But we have this thing where we have to worry about these even roots now. That's the big deal. Odd roots, we can get out negatives or positives, not a big deal. But these even roots make things a little bit difficult, like a square root. So we have this little thing we have to kind of go over, which is that even roots need to be checked. Especially if it does not, you can't maybe figure out if it's going to work out or not from the beginning. But we're going to practice going through the problems and seeing whenever you check it if you get the same answer, assuming that you're doing everything right in between. So even roots need to be checked. So when you do these, it says check for extraneous solutions. For the most part, we'll be okay with odd roots. So the ones that need to be checked in this one specifically is B, C, and D. A, we don't need to check. There's a cube root. But these are the ones with a fourth root, a square root. We don't know if it's going to work out or not. Not sure. Got to check them. The next one we have a square root. Check it. Cube root, we probably don't have to check it. If you do check these ones, which I would like you to practice checking them anyway, these ones should turn out to be okay for the most part. 3 also has a challenge problem in it. You do not have to do that, but you could try it. I'd like you to try it. And then if we get to these last 6 here, fifth root, hopefully should be okay. Fourth root, maybe not. Third root should be okay. Third root, okay. Sixth root, another even, maybe not. And then eighth root, we also have to check. These are the ones that really could mess us up with the imaginaries. But that is the end of this chapter. We're going to move on to chapter 9 next. And that's a wrap on 8.8.